Association rules are useful for discovering relationships between categorical items in a dataset. Association is often used for market basket analysis to discover products that are frequently bought by the same customers. For this example, we have web traffic data and want to see sequences of actions commonly performed by users. To generate association rules, we need two different types of data sources. The first is a reference data source that has a single variable unique primary key, in this case an ID for each web session. This will be used along with an event data source, which will frequently have multiple entries for the same session and therefore no unique primary key. For this example, we'll use data from the samples folder created when SAP InfiniteInsight was installed. Here we'll select the website references document. Next, we need to provide a data description to correctly identify the characteristics of the data, such as the data type for each column. We can click Analyze to get SAP InfiniteInsight to generate a data description automatically, or we can load a separate data description file. Note that you must validate the results if you use an automatically generated data description. For this example, we'll load a description file. Here we can see that the reference data source has a single column, session ID. The description document identifies the column as containing integers that should be treated nominally, meaning that the numbers are identifiers and not values to use in calculations. Next, we need to specify the events data source that contains the website interactions. Now we need to provide data descriptions of the columns of events data. For this example, we'll load a description file. Now we can see the 5 columns from the events data source and the associated data types. Now we need to specify how we want to extract rules from the data. In the column selection area, InfiniteInsight has recognized session ID as the key for joining the reference and event datasets. It also recognized page as the item column we're interested in. In the parameter setting area, we can specify limits on the rules we'll consider. Minimum support is the minimum percentage of the time that the rule must occur in the dataset. For example, for a rule stating that customers who buy toothbrushes also buy dental floss, the minimum support is the minimum percent of the time that this combination of purchases must occur for us to include the rule. Minimum confidence is the minimum percentage of the time that the rule must occur when the initial conditions are met. For example, the minimum percent of the time that customers who purchase toothbrushes must also purchase dental floss for us to include the rule. The maximum length value is the maximum number of items that can be included in a rule. The default value of 4 means that the longest rule we will consider includes 4 items. For example, that a customer who purchases a toothbrush, mouthwash, and sugar-free gum also purchases dental floss. The Activate Sequence Mode option is useful when we're interested in the order in which events occur. For example, rather than considering only customers who buy a toothbrush and dental floss, we might be interested in customers who first buy a toothbrush and then buy dental floss. We're looking at sequential actions of website users, so we'll activate Sequence Mode. Here we can see an overview of the modeling results. In the Association Rules Results area, we can see that 20 rules were found that met our conditions. First, we'll look at the statistical reports that were generated. Here we can see details about each of the 20 rules that were generated. Each rule contains an antecedent and a consequent. In the rule toothbrush then floss, toothbrush is the antecedent and floss is the consequent. In our example, the rules are sequences of interactions on a website, so the rules are about the order in which items were clicked. For each rule, we can see the confidence, KI, rule support, consequent support, and antecedent support. Confidence measures the percentage of the time the antecedent conditions are met that the consequent conditions are also met. For example, the percentage of the time that someone who purchased a toothbrush also purchased floss. KI is an information indicator showing how much of the consequent is explained by the antecedent. A ranking of 1.0 indicates that the consequent was always accompanied by the antecedent. For example, with the toothbrush and floss rule, a KI of 1.0 would mean that every sale of floss was accompanied by the sale of a toothbrush. Rule support is a measure of the percentage of all sessions analyzed in which both the antecedent and consequent occurred. Consequent support is the percentage of all sessions that met the consequent conditions, and antecedent support is the percentage of all sessions that met the antecedent conditions. Now we'll explore the association rules in more detail. Here we can see the antecedents and consequents found in the 20 rules that met our conditions. Note that some items appear in both lists, meaning that the item was an antecedent in some rules and a consequent in others. On this screen, we have the option to define numeric filters to further restrict the antecedents and consequents we want to consider. In this example, we'll click Search without setting any numeric filters. This will allow us to see more details about all of the generated rules and decide which ones we want to include in our model. Here we can see additional details about each of the rules. Many of the measures that display here are specific to sequence mode, such as sequence KI. With standard KI, rule conditions are considered to be met when the antecedent and consequent occur in any order. Sequence KI considers only those cases where the antecedent occurs before the consequent. For this example, we'll sort the rules by sequence KI and remove any with values below 0.94. The column is now sorted in ascending order. We can see that the first 5 rules have a sequence KI below 0.94, so we'll remove them from the model. Now we'll display the remaining rules as a graph. Here we can see a visualization of all 15 of the rules that will be included in our model. Each blue circle represents an item, which can be an antecedent, a consequent, or both, and each arrow represents a rule. The size of each circle reflects the number of sessions that include the item, and the width of each arrow indicates the KI of the rule. Note that the panel on the left lists each item that is part of at least one rule, and allows us to select items to visualize in different combinations if desired. We could analyze these rules to make recommendations on ways to improve the website to generate desired outcomes, or apply the model against new datasets to predict how users will respond. Once we're satisfied with the set of rules, we're ready to save the model. We'll save the model to the same folder as the data source documents. Now we'll apply the model against a new dataset. First, we need to select the new dataset against which we want to apply the model. Next, we need to specify how we want to apply the model. For this example, we'll use the default setting, predicted value only. This means that for each record in the new dataset, the output will predict the next action by applying the rules that we included in our model. The output will also include the session key for each record and the ID of the rule used to predict the next action. Now we need to enter a name for the model output. Now we need to select the events data source to apply the model against. Now we'll view the output. Here we can see the session ID for each record, along with the rule used to predict the consequent, the predicted consequent, and the KX index of the record. You now know how to generate association rules in SAP Infinite Insight. For more SAP Business Intelligence tutorials, visit sap.com/learnbi.